Hey guys, so we're going to go ahead and go through example number 13 in lesson number 18 here. We're skipping now examples 10, 11, and 12 and go into a different type of set, which we'll call orthonormal sets. And in order for something to have an orthonormal set, we have to have two conditions. The first condition is the fact that they are orthogonal, which we have been talking about this entire lesson. So this will be very fast to figure out, are they orthogonal sets? And then secondly, are they unit vectors? Which we also are able to do easily. If the answer is yes to both these two questions, so are they orthogonal sets and they also are unit vectors, each individual one of those are unit vectors, they are what we call orthonormal sets. If we do have orthogonal but not unit vectors, all we have to do is normalize the vectors. We've done this before. We'll do this again to produce unit vectors, and then that will be an orthonormal set. If it's not orthogonal, then we're good. The answer would be no, that it's not orthonormal. All right, so let's go ahead and get started here with this first part right here. So the first part here is, are these orthogonal? And again, guys, we've done this so much now, so we pretty much know what to do. I'm going to go ahead and call this U and call this V. And so remember, in order for us to be orthogonal sets, we've done this many times now in this lesson set, we just have to do the dot product and ensure that it's equal to 0. And in this case, you know it's going to be, right? You can see what we're going to do here. So negative 0.6 times 0.8, and then we're going to add to that 0.8 times 0.6, right? So we get negative 0.48 plus positive 4.48, and we get the fact that it's orthogonal, so it's an orthogonal set. So we're good on that part. The second part of the question is, are these both unit vectors individually? All right, so we want to look to see, is the unit vector. So remember, what is a unit vector? A unit vector is the magnitude is 1, right? The length of this vector is 1. So in this case here, we're going to see if this matrix distance here is 1. So we're going to do that. Well, why do we do this? We take the square root of each individual component, and we're going to square our both components here. So we get negative 0.6 squared is 0.36. And then we do 0.8 squared, which is 0.64. And we get this ends up being the square root of 1, which is 1. So this is a unit vector. Similarly, we do V. You already know it's going to be a unit vector because it's the same numbers. Instead, it's just they're both positive, but we want to show it just because. So we want to do 0.8, squared, and then 0.6 squared, which then gives the same values, just in a different order, which gives us a square root of 1, which is equal to 1. So we're good. So in this case, we can say that yes, these are orthonormal sets. Okay, so easy. That's all we gotta do. We had to do work for it. We just had to show that that's true. All right, for the next part here, we're gonna do the same thing. We're gonna call this U, and we're gonna call this V. Actually, that looks like a U, so let's go ahead, and this is gonna be our V. So the first step that we're gonna do here is we're going to set them the dot products and see if it actually gives us. Sorry, that looks like a U. Okay. All right, so when we do this, we get negative 2/3 times 1/3, and then 1/3. Oh, my computer must be getting tired because it's now lagging, so it's okay. We know what we're writing here, hopefully. All right, so looks pretty bad. Again, that's not my handwriting. This is my computer is being very laggy here. So I'm taking negative 2/3 and multiply by 1/3. 1/3 times 2/3, and then 2/3 times 0, and we will get the fact that this is actually 0. All right, so that's our first part. Since that's the case, we're now going to look at each individual. Let's see how this is going to go. Hopefully this will go nicely for us. We're going to find the magnitude of our U. It's like I said, I'm going to go a little bit slower with my writing, so hopefully my computer can catch up a little bit. So we're going to take negative 2/3, and we're going to square it, and we're going to add 1/3 squared, and then we're going to do 2/3, and we're going to square it. When you do this, you are going to get 1, all right? So you're going to get 4/9 plus 1/9 plus 4/9. So 4/9 plus 1/9 plus 4/9 is 9/9, which is going to give you a 1. So yay on that. Our magnitude is actually 1. So we're actually very happy about that. When you do the magnitude for V, we're going to, again, do 1/3, square that. And then we're going to do 2/3, square that, and then plus 0, quantity square. When you do this, you're going to get square root of 5 over 3. All right, you get square root of 5 over 3. So 1/9 plus 4/9 is 5/9. Take the square root of 5/9. You get the square root of 5 over the square root of 9, which ends up being 3. So this is not going to be a unit vector. So what we're going to end up doing here is we're going to normalize this vector. All right, so I'm going to scoot this up a little bit so we have our vector. So normalize our vector v. All right, so we're good with. So what we're going to do here is, remember, is we're just going to take our component. So what is our unit vector for this? So we're going to do v over the magnitude of v. So we're going to go ahead and do our big old piece here. We're going to take our first component, which is 1/3, and we're going to put it over the square root of 5/3. We're going to take our 2/3, so our next component, and we're going to take it over the square root of 5/3. Again, I'm so sorry about my handwriting. And then we're going to do 0 over square root of 5/3. So this is how we normalize our vector here. So we take each component of our v over the magnitude of each one. And just to make this look a little bit better, we're going to go ahead and multiply both top and bottom by 3. So we're going to get our first component is 1 over the square root of 5. And then we're going to get a 2 square roots of 5 is our second component. Again, multiplying both sides by 3. That's supposed to be a 5, guys, sorry. And then 0. So my computer is slowly dying here, but we're good here. So 1 over square root of 5, 2 over square root of 5, and 0. So this right here, so our final product here, this is a normal orthonormal set. So our u and then our normalized v. All right. So that is our answer for our problem here. So hopefully that makes sense. So just a little quick summary. When you're trying to find whether something is orthonormal or not, you just have to ask yourself, is an orthonormal set? Again, dot product has to be equal to 0 for all the components. If there was a w here, we'd have to do uv, vw, and uw. And then we have to look at each individual and make sure that they are all unit vectors. If they are, done, awesome. If they're not, all we have to do is just normalize, right? That's what we did here. We normalized the vector, and that vector is our part of our set now, our orthonormal set. All right, guys, I will see you guys in class later. So have a good one, and see you later. Sorry, cut myself off. Bye.